finding new and fancier ways to ask for salt on your popcorn or french fries, and what exactly is in your SpaghettiOs. All that and more on today's Moment of Science.
In chemistry, we're going to be talking about the study of matter. And what is matter? Matter takes lots of flavors, okay? Matter is the stuff that makes up everything, all right? Everything is made of matter. I'm made of matter. You're made of matter. The screen that you're watching is made of matter. Okay, everything is made of matter. Now, matter comes in three varieties. It can come in the form of elements, it can come in the form of compounds, or it can come in the form of mixtures. All right, the first of these that we're going to talk about is elements. All right, and you'll see before me I've got three different elements laid out here, and they all have different properties, but we're going to talk about properties next time. But for right now, we need to have an understanding of what an element is, what a compound is, and what a mixture is. All right, so the elements that I have before me: sulfur, aluminium if you will, and copper shot over here, okay, copper BBs. And these are all elements. They are pure elements. There's nothing else in them to make them different. And they have properties that make them that way, and that's what we're going to be discussing in the next Moment of Science. But for right now, understand that when something is pure, it is exactly one element. If I were to take and show you the periodic table, it would be one square of the periodic table. Okay, so for instance, this is sulfur, elemental symbol S. Okay, this is aluminum, elemental symbol Al. This is copper, Cu. Okay, now only that. There's nothing else in here. Okay, I can promise you that there's nothing in this copper. There's nothing in this aluminum besides aluminum, and there's nothing in this sulfur besides sulfur. And when we have more than one, that's when we get compounds or mixtures. Now, the second category of matter is a compound, okay? And a compound is when you take two different elements from the periodic table and you kind of squish them together, all right? And compounds they can be huge, they can be made of many, many elements, or they can be real simple and made of only a few. All right, for instance, right here I have H2O, okay, which is water, and I have alcohol right here, 70% alcohol, all right? Now, this is a little sketchy because this is actually a mixture, which we're going to talk about here in a second. But, okay, the elements that are in here, the compounds that are in here are what make up the substance. This is pure water, all right? Now, there's nothing more in here than H2O, okay? Take it real simple, okay? If you were going to a restaurant and wanted to get some salt on some french fries or ask for no salt, all right, you could use the term sodium chloride, okay, which we're going to be talking about here in a second as we go along into naming, but sodium chloride is just a fancy name for table salt. All right, and table salt is a compound. It takes one sodium ion and one chlorine ion and puts them together. All right, this takes two hydrogen atoms and one oxygen atom and squishes them together. Okay, this right here, alcohol, is a little bit more complicated. It has three elements that are in it. It has carbon, hydrogen, and oxygen. Okay, all three of those elements combined in such a way to give us isopropyl alcohol. There are tons of other types of alcohols, but this is one that you can get from the store. And we use it whenever we're disinfecting cuts and things like that. Okay, now isopropyl alcohol, again, is a compound because it contains C, H, and O, carbon, hydrogen, and oxygen. Now, what makes a mixture different from a compound, okay? Mixtures are composed of multiple elements, but they're just kind of sitting there in a stew, okay? They can also be composed of multiple compounds or a combination of the two, a little bit of part A, a little bit of part E, some compounds and some elements. For instance, think of the atmosphere. The atmosphere that we breathe every day, okay, contains nitrogen, oxygen, CO2, all kinds of other gases just kind of hanging out there, okay? Now, they're not bound together. In a compound, sodium and chlorine, when they're bound together, they're a compound. But in the atmosphere with all those elements sitting around, it's not a compound by any means. They're not bound together. Now, another type of mixture is this, okay? What I have before you is a thing of SpaghettiOs, okay? In the SpaghettiOs, I'm sure if you were to look at it, you would notice that it has meatballs and it has the noodles. It would also have the tomato sauce, okay, at the just general level. But when you actually break it down, there's things like salts in there. There's the elements that make up the meatball, okay? Lots of things that actually go into giving SpaghettiOs the flavor that they have. Now, that is something called a heterogeneous mixture. Heterogeneous mixture, you've probably heard it said that way before. Because you can see the different parts, all right? You can see every different part. You can't necessarily see the salt or anything like that, but you can see the meatballs, you can see the noodles, you can see the tomato sauce. It's all differentiated real easily. Think of a can of mixed nuts when you're there too, okay? We have chestnuts, peanuts, things like that, all sitting together in a nice mix, and you can pick out the ones you don't like, okay? For instance, I don't like raisins. Okay, so I can pick the raisins out of my trail mix using that kind of scenario in a heterogeneous mixture. Now, that's different than something called a homogeneous mixture, homogeneous mixture. Okay, in a homogeneous mixture, much like the one that you'll see before me, otherwise known as Kool-Aid. Oh yeah. Okay, in Kool-Aid, it is made of different things, okay? But when you look at it, it doesn't look very different. You can't see the stuff that it's made of. Okay, inside of Kool-Aid, we have sugar, okay, made it myself. We have the Kool-Aid mix itself, and we have water. Okay, but if you were to look at this just generally, you can't see the different parts. Okay, that's what makes this a homogeneous mixture, the same throughout. Homo meaning same, geneous meaning throughout, okay? The same throughout, we'll go with that, in a mixture of Kool-Aid. So, the difference between these two is in a homogeneous mixture, you can't see the different pieces. In a heterogeneous mixture, you can. Okay, and we have all different types of those mixtures, and we'll be talking about those and kind of investigating those in class next.
Now, if you were to look at the elemental symbols of compounds, elements, and mixtures, it would look a lot like what's on the board behind me, and we're going to discuss that. The first of these is iron, okay? Iron bars or anything made of iron is composed completely of iron, ideally, okay? Unless it rusts and then it turns into a compound. But iron itself, when it's fresh, is Fe, just straight iron, nothing more. Okay, now if I were to take iron and combine it with iodine, okay, or even oxygen, I would have iron iodide or iron oxide, okay? Iron oxide is rust. So if I were to have a compound, that would be where I take one element and physically bind it to another one. They're stuck together, okay? Iron stuck on iodine and iodine stuck on it, okay? Something to that effect. That's an old school song. Y'all probably don't know what I'm talking about. But a different definition would be a mixture, okay? Mixtures, those of you who are in band, brass is a mixture, okay? And brass is a mixture of zinc and copper in different proportions, okay? And that gives it different properties. But copper and zinc, without being physically stuck together, okay, make up brass, all right? And again, this is how we actually notice a difference between elements, compounds, and mixtures based on their elemental symbols. Come to class next time prepared to differentiate between all these elements, compounds, and mixtures. We'll see you next time on A Moment of Science.